Good morning, everyone. Now, in this problem, we are going to find the mutual reactance Xm of the coupled circuit. First, let us analyze the circuit. Here, there are two windings, one primary and one secondary, and their mutual coupling is denoted as JXM. Now, as per dot rule, the current is entering in this dot and the current is leaving from this dot. So the sign of the mutual coupling is to be denoted as minus JXM. If both the currents are entering, then we can give the sign as positive. Since one current is entering and another current is leaving, the sign is to be considered as negative. Now, I am going to apply KVL for the primary winding. So, 5I1 plus J5I1, and to consider the mutual inductance minus JXM. The mutual inductance in I1 is due to I2. Therefore, minus JXM I2, which is equal to 100. The angle is going to be 0, so we no need to consider that. So, if I take I1 commonly outside, 5 plus J5 minus JXM I2 is equal to 100. This will be equation number 1. And then for the second loop, or for the secondary, if we are going to apply KVL, J12 I2 plus 8 I2 minus, again the mutual coupling in the secondary is due to the primary current, which is I1, which is equal to 0. Again, if I take minus I1, then it will be JXM, and then plus I2. If I take commonly outside, then we will get 8 plus J12, which is equal to 0. This is second equation. If we are going to write the equation in matrix form, we will get 5 plus J5 minus JXM and minus JXM 8 plus J12. Corresponding currents are I1, I2, and the sources are 100 for the primary and 0 for the secondary. Now we have to sort this through Cramer's rule. So delta can be given as determinant of 5 plus J5 minus JXM minus JXM 8 plus J12. As we all know, we know how to solve for delta, right? So if we solve for delta, the answer would be delta is equal to minus 20 plus 100G plus XM square. And we need to find I2. For that, we need delta 2. So delta 2 can be written as 5 plus J5 minus JXM and 100, 0. So delta 2 is JXM 100. Okay. So we are going to find I2 now. I2 is delta 2 divided by delta, which is equal to JXM 100 divided by minus 20 plus 100G plus XM square. Now, there is a hint given in the problem. The average power in 8 ohm resistance is 100 watts. So, how should we represent the average power through 8 ohms? P through 8 ohms is equal to 100 watts. And this can also be represented as I2 the whole square into 8, because I square R is the power. Now we all know I2, so substituting for I2, JXM 100 divided by minus 20 plus 100G plus XM square into 8, which is equal to 100. We can cross multiply this and further simplify this, or else we can first take the magnitude. So when we take the magnitude for this function, the answer will be xm 100 divided by root of, there's supposed to be a square, root of minus 20 plus xm square the whole square, because this is supposed to be the real part, and plus 100 square. And the magnitude, the whole square into 8, which is equal to 100. Further, we are going to simplify this function. We can take square on both sides. So if we take square on both sides, no, if we take the square that is corresponding to this term, then we will get 10,000 xm into 8 divided by, the root will get cancelled, so minus 20 plus xm square the whole square plus 100 square, which is equal to 100. Now cross multiplying and simplifying, we will get 10,000 into m into 8 divided by 100, which is equal to, I'm going to expand this form here, which will be 400 plus xm power 4 minus 40 xm square plus 100 square, which is 10,000. Okay. I have missed one square here, so let me add that, xm square. Okay, now 800 xm square, which is equal to 400 xm power 4 plus minus 40 xm square plus 10,000. Bringing all the terms to the one side, we will get xm power 4 minus 40 xm square, should be plus, then plus 800 xm square because we are bringing it to the right hand side. This term would be minus, this term would also be minus. Okay, and then adding these two terms, 10,400, which is equal to 0. Now we can add these two terms together, xm power 4 minus 840 xm square plus 10,400 is equal to 0. Now to simplify this into quadratic equation, I am going to assume xm square is equal to x. So this would be x square minus 840x plus 10,400, which is equal to 0. Now we can solve for this quadratic equation. So solving it, we will get x is equal to 827.431 or 12.569. Now to physically realize the circuit, we are going to choose x value as minimum as possible, which is 12.569. We all know x is equal to xm square, which is equal to 12.569. Therefore, xm is equal to root of 12.569. xm is equal to 3.54 ohms. This is the mutual inductance for the problem. Thank you.